I want to find cosecant of u minus v, given that sine of u is negative 7 over 25, and cosine of v is negative 12 over 13 in quadrant 3. So the first thing I'm going to do is rewrite cosecant of u minus v as 1 over sine u minus v. And here I'm going to use the fact that sine of u minus v is sine of u times cosine of v minus cosine of u times sine of v. We know what sine of u and cosine v are, but we do not know what cosine u and sine v are. So in order to figure them out, we want to draw a right triangle in the third quadrant. We're given, first we'll do angle u. So we're given that sine of u is negative 7 over 25, which means sine is opposite of our hypotenuse. So we're going to put a negative 7 on the opposite side. Hypotenuse is 25. We want to complete this right triangle, so we know that this is a Pythagorean triple that is 7, 24, 25. But because we're in the third quadrant, we want to make sure that the 24 is negative. And from this, we figure out that cosine of u is adjacent over hypotenuse, which is negative 24 over 25. Next, let's do the same thing with angle v. We're given that cosine of v is negative 12 over 13. So the adjacent side is negative 12. Hypotenuse is 13. We're in the third quadrant, and we can figure out this right triangle because we know it's a Pythagorean triple. It's a 5, 12, 13 triangle. 5 is negative because we're in the third quadrant. And we can figure out that sine of v is the opposite over hypotenuse, which is negative 5 over 13. Now we can come back and figure out what is 1 over sine of u times cosine of v minus cosine of u times sine of v. We're going to plug in the respective trig values, simplify it, and get that cosecant of u minus v is negative 325 over 36. And that is our final answer. Next example, we want to find cosine of arccosine of x plus arcsine of x. So in order to do this, we want to use the sum angle formula for cosine. So cosine of arccosine of x plus arcsine of x is cosine of arccosine of x times cosine of arcsine of x minus sine of arccosine of x times sine of arcsine of x. Cosine of arccosine of x are inverses of each other. So whenever you compose inverses, you're always going to get x. Here we have to be careful that x is in the proper domain. Similarly, with sine of arcsine of x, they're inverses, and when you compose inverses, you get x. So that leaves us with x times cosine of arcsine of x minus x times sine of arccosine of x. So we're going to let arcsine of x be angle theta, and so that means that sine of theta is x. And we're going to let arccosine of x be angle gamma, which means cosine of gamma is x. So with the arcsine and the arccosine, you're just flipping the angle with the length. Okay, now let's look at this triangle first. Let's say it has angle theta. We know that sine of theta is x, which means opposite side is x. Hypotenuse is 1. We can figure out the missing side by using Pythagorean theorem and get that it's square root of 1 minus x squared. So what we want to find is cosine of arcsine of x, which comes down to finding the cosine of theta, right? Because arcsine of x, we said, was theta. Cosine of theta is adjacent over hypotenuse, which is the square root of 1 minus x squared. Similarly, we're going to let the angle be gamma. We know that cosine of gamma is x, so that's adjacent over hypotenuse. Notice this is basically the same triangle, except the x is the base in this case instead of the height. So the missing side should still be the square root of 1 minus x squared. And when we find that sine of arccosine of x, well, we do that arccosine of x is gamma. So sine of gamma is opposite over hypotenuse, which is the square root of 1 minus x squared. So if we go over here, cosine of arcsine of x and sine of cosine of x are the same thing. They're being multiplied by x and then subtracted, so we get 0 as our answer.